Hey guys, thanks for the throw. We're here with Andi Mann, who's newly appointed Chief Product and Technology Officer for Apica, and we're talking about telemetry data because, well, there's more of it than ever. Andi, welcome to the show.
Hey, Mike, it's great to be here. Thank you.
All right. Congratulations on the new gig, but I have to ask you, have we somehow gone from, I remember it just feels like a few short years ago where everybody's saying we don't have enough data to analyze because not enough stuff was instrumented, to now we have instrumentation and more data that we know what to do with. So, I guess, is this becoming too much of a good thing?
Yeah, look, it is to an extent, and this is actually a logical progression because we started with a lot of packaged applications that didn't actually give us a lot of insight. You couldn't look inside them. And when we talk about observability, that's what it's all about. It's being able to look inside a system and see what is happening based on the external sort of telemetry from that system. So we had packaged systems, NetSuites and SAPs and Oracles and Siebels and all these sorts of things, not to mention all the financial apps and everything like that, which weren't particularly well instrumented. So we had to do unnatural acts, right? We had to do things like synthetic transactions. We had to do things like real user monitoring at the end point and looking at what's happening, monitoring on fake signals that we're generating in order to get insight. This fundamentally changed around development on cloud. And we started to create these applications, to start with, custom developed. Secondly, built on these sort of atomized architectures. So they're all talking, components and serverless bits and servers and virtual and all talking to each other. This created the data that we sort of needed, we were sort of missing. So there's still a need for things like synthetic transactions, but we're getting a lot more information directly from the applications themselves. So this is all this telemetry data. And obviously, as we're building more and more atomized applications, we're getting more and more data to understand what those applications are doing. So for a single monolithic application, you might have a whole bunch of signals coming out of the server, the storage, the network, the app. For an atomized application, you've got content and data, log files, events, metrics, traces coming out of every component all the time. So as we continue to build, and everyone's building new things, everyone wants to grow their business, do new things in new ways, beat competition. So the way we do that is we create new products and services, we bring them into market. We have to have technology to support them. So we're creating a whole lot more applications, and AI is helping us create even more applications and even bigger ones. And we're using different architectures and technologies and methodologies to create those applications, which are creating more data as well. So this is just exploding. Telemetry data is nuts. And we do need it. The more data we need, the more data we have, yes, the better. But wow, mate, we are paying for that data. IT ops, devs, CIOs, CTOs, every year their bill for observability data goes up and up and up. And we're seeing data volume increases like 70, 80%. And pricing increases are sort of, a little bit linear from most vendors. So yeah, look, for a lot of the customers I talk to, this is a prime concern. They don't want to get rid of all the data. They want the data to be meaningful and to be able to handle those increases without blowing their budgets.
Mm-hmm. Theoretically, I think you can route a lot of this data to, I don't know, an S3 bucket to reduce your costs. But I think the challenge then becomes, well, how do I get it back when I need it? So, how do I manage that whole end-to-end process?
Yeah, I mean, it starts with routing the right data, because you're absolutely right. You don't want all your data in one place necessarily. You want it where you need to use it. And a lot of data is, I won't say meaningless or pointless or worthless, but it's certainly low value. You think about a verbose application, which is issuing log data statements, log file statements that are just saying everything's good, right? Yes, transaction succeeded. Honestly, as an IT operator, I do not care about that. I do not want to know. It doesn't come into my event analysis. It doesn't come into my problem determination or prediction. What I want to see is when it doesn't work. So start by filtering. Don't even send stuff that you don't want to see that's not meaningful for you. And, every now and then you'll get a developer turning on verbose mode with logging, right? And all of a sudden you're sending terabytes. In one of my earlier lives, I saw a customer turn on verbose logging, and they were literally is sending blob files, binary large object files, screenshots of applications in PNG format being sent as binary log messages because logging was verbose, right? We don't need that. So filter the data, make sure you're getting the right data. Do things in the pipe instead of the expensive ingest and storage layer. So to do things like, and this is what we're doing, is filtering and masking PII and confidential information, and filtering out noise, and crunching a single log line into maybe a metric. Instead of sending a whole verbose line that says I got a 404, just send a fail 404. You're already saving data. You're saving transmission costs, storage costs. Makes it faster as well. And then, absolutely, select the right repository for the right data. Various observability platforms can get to multiple locations, their own proprietary data stores, maybe an S3, maybe a Hadoop database, maybe a Snowflake. These are all different repositories based on different data needs, access time, how important it is to things like troubleshooting and triage, and how important it is to predictive analytics and preventing problems. So there's three key elements here. One is get the right data in the first place, process it in the pipe to make sure you've got the tight data set that you can work on, and then make sure you're storing in the right location.
I guess the first question that comes to mind is which pipe, because we have DevOps pipelines everywhere, and no one's quite sure exactly where to insert the telemetry data management. And is it everywhere, or is there a focal point? What do we need to think about?
Yeah, look, data telemetry, it is potentially everywhere. And look, I've done a lot of work taking data out of development pipeline and the software development lifecycle to understand the activities happening in that work stream. So, for example, taking log data out of GitHub, out of Jira, out of Jenkins or Puppet or Chef in terms of deployment, taking log data out of test tools, test automation, for example, code compliance tools, and being able to take all that data. So look, pipelines are pipelines. There's data everywhere. I think the pipelines that we're most interested in are the pipelines coming out of the telemetry data systems on servers, infrastructure, applications, middleware, that sort of thing. We're looking at helping IT operations teams and development teams to understand things like performance, utilization, capacity, failure, root cause. They're the sort of data items that I'm most interested in working with right now. So we're taking data out of things like servers and StatsD, open telemetry, any open telemetry collector, for example, shipping that into our own proprietary processing system, Apica Flow, so that we can then look at that data, understand it, and then forward it to the right repository, whether it's a Splunk, a Datadog, a Dynatrace, a New Relic, a Grafana, an Elastic. Maybe it's most, because most customers tend to have 3 or 4 of these platforms, by the way. So what I'm talking about is this performance, availability, fault, failure, error, these sorts of data lines, both logs, metrics that say, am I running fast or slow, for example, traces, intercommunication between different application components. So these are the data streams that are providing information about whether my application is up and running well, delivering responses or not. That's the sort of stuff that I'm talking about. But you're absolutely right. There's data everywhere. There's data coming out of IoT devices, point of sale devices, out of mobile devices. These are all potential candidates for data streaming that CIOs and CTOs need to worry about, because they're all going to cost time and money to process. And so, the same principles apply. What I'm looking at is that telemetry data for IT operations and performance management. But there's so many different data streams you could think about in this conversation.
So to your point, do I need a specific data engineer who knows about the nuances of telemetry data specifically, or is this something that can be incorporated into everybody's kind of day job as it is?
Yeah, look, it depends on it's IT, right? So it always depends. It depends on what you're using the data for and who's using it and how cluey they are and what tools you've got to make it easier. If you're handling these data pipelines by yourself, then absolutely you're going to need a data engineer to figure that out. You might actually need a network engineer as well, because that's pretty tightly related. But with good tooling, you take care of that, right? It's why we use tools in the first place, to save ourselves time, money, effort, knowledge, resources, all this sort of stuff. So if you apply good tooling to this, then a lot of it becomes a lot simpler. You can use graphical interfaces to be able to define filters, deduplication, masking. These sorts of things become a lot easier because they're just straight through a GUI. Maybe if you're a developer, you want to use the API or a CLI to do it, but you can still do that as a developer, as an operator, if you have a knowledge of what the application is doing and why. Everyone needs systems thinking, I think. But if you don't have that kind of tooling, look, it gets complicated. You're dealing with binary data streams and you're doing the translations and network interfaces. You're trying to get to layer 6, layer 5, maybe, in terms of the data content and the payload to understand what the contents are. You could also, by the way, if you're doing it manually like that, come against some pretty serious security and compliance implications around individual data scientists being able to look at confidential data, see it, access it, work with it, maybe leak it. But when you provide good tooling, then you get to do the CLI or UI setup. You get to have security and compliance factor built in, including things like role-based access controls and automatic masking of obvious PII, like telephone numbers or credit card numbers or social security numbers, for example. You also get the ability to see into the pipe, into the payload, without necessarily having access to the data itself. So you've got better compliance and governance. So look, mostly this is the sort of thing that developers and operators would collaborate on, DevOps being the big thing, right? Still, collaboration. You probably don't need a data scientist, though, if you have the right tool sets.
Mm-hmm. So will maybe I see something that looks like an AI agent emerge to help me manage all this stuff? It seems like it's a good candidate for these jobs. Of course, in my mind, good candidates for AI agents are anything that I don't enjoy doing. So is this something that's going to be high on people's list of, I want an AI agent for that?
Yeah, look, I don't want to give away what's on my roadmap right now, watch this space. But speaking generally, think about you're exactly on the right track, Mike. You think about, this data is potentially complex. It's high volume for sure. It's high cardinality as well. So it means there's lots of changes in it. There's not a lot of that's similar. And so that's the sort of perfect candidate for automation and AI to take care of, right? This vast data set of hard to detect patterns that do exist within the data stream, that a human looks at it and goes, I just can't even, pun intended, grok any of this. And so you're absolutely right. AI in the pipeline is going to be super interesting. You get to do a bunch of stuff just based on pattern matching, which, advanced machine learning, AI, let's, see what it is. But then you can apply LLMs based on known knowns. So think about Windows System Log as a very simple example. Windows System Log has a lot of known content. You know what it means, and it's documented well. So now we have an LLM, right? We have documentation in the log itself. Now we can start to apply AI techniques and generative AI techniques to learn from documentation what is meaningful in that log, and only collect and forward to these expensive observability platforms those log messages that actually mean something. Or even better, transforming those log messages into much smaller bytes so that you're reducing traffic but still getting full accuracy on your data stream. So look, this is coming on. It's coming on strong. I actually think that if you can't apply AI at the source, I'm talking within your application code, to be able to restrict and limit what data you're sending out, the next best place has got to be in the pipe, right?
True. Well, let me ask you a follow-up question on that, because it seems to me, therefore, based on what you were saying, that I don't know, am I going to see like an LLM for telemetry data sometime, or is there going to be specific ones for that, or are there going to be these general purpose ones that I kind of bend to this purpose?
Yeah, look, I don't know the answer to that. If I had a crystal ball, I would obviously be a very wealthy man and maybe sitting on an island in Hawaii or something. But I think you're on the right track. I don't think it's going to be general purpose for this. I think it's such, I want to use the term arcane knowledge. It's very specialized. It's almost wizard-like, some of the knowledge that people have about these log messages, traces, how they work together. And so I think that it's going to be based on maybe a small language model instead, or maybe individual unique language models for each business, because this is a challenge as well as the compliance angle. If I want to create an LLM based on, something like system log is easy. But if I want to create an LLM based on an application log, now I need to know what that application is. We used to know that with packaged applications. Now we've got non-packaged, custom applications. So I can see a pathway for an AI to get trained on both the application code, the application documentation, and be able to use that training in a small language model way to be able to filter out meaningless sort of verbose debug kind of stuff versus meaningful Sev1 error kind of stuff. The challenge is, again, whether that data is available as a large public LLM or whether it's just unique and arcane to that one business, because that's their application and their intellectual property as well. So it's going to vary. I think I would love to see, for example, and we've got this for a lot of the traditional observability data sources, things like Windows System Log or Security Log, things like StatsD, Collect D data coming out of infrastructure. We've got good knowledge, and that sort of content could be used as a training for an AI, Gen AI, to be able to work with that data on the pipe dynamically. But I think it's going to be more complicated than that, simply because of the custom applications, proprietary data, confidentiality, and honestly, people still do stuff on premises. And so public cloud data doesn't come to apply to that use case either. So it's going to be a varied way of looking at it. I'd love to see it sort of universal across the world. The way we do some of that stuff with security penetration and attacks and 0 days, we're sharing that information through things like MITRE and other organizations. It'd be great to be able to see that for at least package applications, but it's always going to have to be ameliorated with a little bit of proprietary knowledge and internal training for those custom applications.
Mm. So what is that one thing you see people doing with telemetry data that kind of just makes you shake your head a little bit and go, folks, I wish we were just a tad bit smarter about this?
Oh, mate, dumping it, I think, is the real bad one. People look, and especially at the admin level and the individual contributor and team lead level, they look at these bills they're getting, and they don't want to have to go to the CFO and try and get more money. So they try and take remediation actions to try and get their bill down, to try and, deal with this new application that's coming online. I've got another, 16 gig of data every day I've got to get into my observability platform because of this new application. It's really important. It's competitive differentiation in the marketplace, but I don't want to have to pay a big observability storage bill and transmission bill and ingest bill. So look, I'm going to have a look at what I'm already ingesting and maybe just dump some of it, because it's not that important. It doesn't, I haven't had any problems with that application in the last 3 months, so I don't need to hear from that application anymore, right? That is almost never true. So they're dumping entire data streams. So just saying, oh, look, this application, just turn it off. They're dumping it for certain times. So this application, turn it off between 6 p.m. and 8 a.m. Like we don't have a global economy, right? They're dumping data by cardinality. So let's just summarize all these data points and do that. They're dumping it by just doing sampling. So I'll sample my data stream. So once every 2 seconds, I'll take a data point. What happens if the problem occurs within those 2 seconds? So they're doing the best they can, Mike. They haven't got more money. They haven't got more storage. They need to do what they can to accommodate these new this explosion of telemetry data, but they don't always know what the right decision is to make to be able to deal with that data volume increase. Rather than use a sophisticated tool set which can manage that without dumping any data and reduce your cost, they just go for the quick and easy one, which is just like, let's get less data in. And that's going to be problematic over the longer run.
All right, folks, you heard it here. The only thing worse than looking for a needle in the haystack is knowing that you threw the needle away already. Hey, Andy, thanks for being on the show.
Hey, Mike, it's great to talk to you, mate. I really appreciate it.
All right, and back to you guys in the studio.